let's look at a new topic in probability called expected value. We've got some definitions and a formula up here. So let's look at this formula a little bit. Remember, P means probability, and X is going to be some data that we're going to give you in a chart. And kind of in this chart, looking down here, X is the number of hours. Right here, I did the other one with the siblings. In a second, X is going to be how much money we would win. So an expected value is going to multiply that data, like the number of hours, the number of siblings, the number of dollars you're going to win, times the probability. So we've got money, or our data, times probability. And we keep doing this as many times as we might need it. I don't know how many numbers we might be adding together. Here is the numbers 0 through 3. Back on our other page, we had 0 through 4 on that other chart. So we use as many as we need. That's why we go to N right here. N just means however many there are, the number of numbers. So in this case, there were 1, 2, 3, 4 of them. So we would go out to 4 of these numbers. And other times we might only use 2 or 3. So N just says use as many as you need. So let's do this one looking at our hours. I'm going to multiply in example 3 here, the hours times the probability. So it's going to be 0 times 0.3 plus 1 times 0.4 plus 2 times 0.2 plus 3 times 0.1. And I'm going to type that in my calculator. You can type it in all at once, or you can type each one in individually. That's up to you. If you type the terms in individually, you're going to get each term and then add them together to get 1.1 hours. So if we were to randomly ask a child how many hours they play video games each day, electronic games each day, the expected value would be 1.1 hours. It doesn't hold true, right, all the time. That is spreading it out among all of the children we might ask. We're going to keep with the same thing. Down here in example 4, we're just going to do money now. So I get $7 for rolling a 6. Remember, the probability of rolling a 6 is 1/6. The probability of rolling a 2 is also 1/6. So the probability for any number that we roll is 1/6. So if I roll a 6, I get paid $7, and the chance of that happening is 1/6. If I roll a 2, I get paid $3, and the chance of that happening is 1/6. Now you can add, you don't have to, this no payoff otherwise. So that's $0, and that happens with any of the other numbers. So we've got the numbers 1 through 6, and we have 6, and we have 2 taken care of. So that means there's 1, 2, 3, 4 other numbers. So that happens 4/6 of the time. Now, if you don't like the thing in blue, you could get rid of that term, because the 0 is going to mean that it's not going to change anything about our problem. It's just going to be 0 there. We would add on at the end. But technically it is there because we need our probabilities to add up to 1. So 1/6 plus 1/6 plus 4/6 is 1. Again, if that's going to bother you, don't have to put it there. So this would give me 7/6 plus 3/6, which is 10/6. And since it is money, I'm going to round it to 2 decimal places to be $1.67. All right. Let's look at another example of this. This time I've got a raffle, and I'll tell you on this problem, there are a couple different ways to take care of this, because on this one we're going to have to pay for a ticket. So, if you're getting help from a tutor or on my math lab, you might see they might handle the $1 a little bit differently than I do. There's nothing wrong with either method, just kind of 2 choices there. Both choices are good, and I'm fine with both choices. I just have to choose one to show everyone. So this is the one that I'm choosing, but feel free if another method you see works fine, then that's completely okay. I like to take care of the money that the purchase price at the very end. Some people will take care of it at the beginning. So I'm going to jump straight to the prizes and worry about that selling, like buying that ticket for $1 in just a second. So I could win $1,000, and the probability of that happening is 1 over 5,000. That's because there are 5,000 tickets sold and there's only one first place prize. I also could win $500. That probability is 2 over 5,000 because there are 2 of those prizes. And then I also could win $100, and that is 3 over 5,000 because there are 3 of those. Again, you can type it in like that. You can split it up, whatever you're comfortable with. If you want to do a little bit more steps, I'll show that. If you'd rather just go ahead and type it in, you're more than welcome to do that too. And this is going to give me 0.46 cents at some point whenever you type it in your calculator. Now is where I'm going to take care of the cost. Oops. Maybe I darkened it in a little too much there. So they cost $1 each, so I'm going to subtract the $1 off here at the end. I won 46 cents, but I had to pay in $1, so really I lost 54 cents because I didn't win, or I could say I won back less than I paid in originally. So you can have negative expected values. I know on the first page we said we could have negative probabilities, and that still holds true, but these are expected values, or in this case it was expected winnings. So I can have negative answers for those.